Have you ever tried to differentiate a function in Python only to hit a wall? It can be really frustrating, especially when you're eager to see your results. If that sounds like you, stick around because today we're diving into how to use Lambdify to evaluate the derivative of a Python function. I totally get it. Many beginners struggle with differentiating functions in Python, especially when the solutions they find just don't cut it. You're not alone in this journey, and it's a common hurdle for many. Let's take a look at a specific question from a user who wanted to evaluate the derivative of a Python function. They found some answers unsatisfactory and ended up figuring out their own solution. Sound familiar? Let's explore what they did. So what was the issue? The user was trying to evaluate the derivative of a function, but struggled with the limitations of their initial approach. They discovered that by using Lambdify, they could create a new function that made evaluation much easier. And trust me, you won't want to miss the explanation of how Lambdify works. It's a game changer for anyone working with symbolic mathematics in Python. To understand why the user's solution worked, let's first look at the purpose of the Lambdify function. Lambdify converts a SciPy expression into a function that can be evaluated using NumPy. In the user's code, they created a new function called derivative of f. This function is the Lambdified version of the derivative function f prime. This allows the user to evaluate the derivative at specific points. When the user calls derivative of f with the values 1 and 1, it computes the derivative of the original function at that point. This is a powerful feature because it simplifies the evaluation process. However, there are some downsides to using Lambdify. For instance, it may not handle all SciPy expressions perfectly, and performance can vary depending on the complexity of the expression. In summary, the user successfully used Lambdify to evaluate the derivative by converting it into a function that can be easily computed. This approach is effective, but should be used with an understanding of its limitations. So why did this work? By using Lambdify, we converted the symbolic expression of the derivative into a function that can be evaluated numerically. This is a powerful tool for anyone working with mathematical functions in Python. However, there are some downsides to this method. For instance, Lambdify may not handle all types of expressions perfectly, and it can introduce some overhead. It's essential to understand its limitations. Fun fact, did you know that the concept of derivatives dates back to the 17th century? Mathematicians like Newton and Leibniz were pioneers in this field, and now we can compute them with just a few lines of code. Now, let's look at the answers provided by other users. This user provides an alternative approach using Lambdify to evaluate the derivative of a Python function. They explain that by defining a symbolic function with SciPy, they can differentiate it and then use Lambdify to convert that symbolic expression into a callable Python function. This allows for easy evaluation with both numbers and NumPy arrays. Now, let's dive into a different answer from another user. In this alternative approach, the user explains how to use SciPy's Lambdify to create a Python function from the derivative. They show that Lambdify generates a function that can handle basic operations like addition and multiplication without needing NumPy. However, if the function includes more complex expressions like sign, Lambdify will rely on NumPy, which cannot process SciPy symbols directly. They also mention that SciPy has its own plotting capabilities for visualizing derivatives. The user also provides an example where they define a function with sign and show how Lambdify changes the generated function to accommodate NumPy. They emphasize that for plotting, SciPy's own plotting module can be used effectively. That's it for that response. Let's explore another one. This user suggests that instead of using Lambdify for differentiation, you should create symbolic expressions directly. They explain that when you define a function with variable names like x and y, it overrides the symbolic variables, which can lead to confusion. Instead, they recommend defining your expression and then using the diff function on it. To evaluate the derivative, you can use the subs method to substitute values for x and y. If you want to use Lambdify for numerical evaluation later, do it after defining your expression. This way, you can create a fast function that uses NumPy to evaluate the expression with arrays. Here's a quick recap. By using Lambdify, you can easily evaluate derivatives in Python, making your mathematical computations much more manageable. It's a fantastic tool for beginners and experts alike. And there you have it. You've learned how to use Lambdify to evaluate derivatives in Python. If you found this video helpful, don't forget to subscribe for more tips and tricks on Python programming.